Hi guys. So today I'm going to the discussion about diffusion model in machine learning. So we are going to talk about introduction, basically neural diffusion process, convert noise into coherent data, key generative AI task. Then what is component like forward process? Forward means add noise to data. Backward means remove noise from reconstruct data. Objective function minimize noise prediction error. So basically forward, backward, and minimize. Then some application like image generation, image to video, image to text, and so on. Imp handling is missing or demand section of image. Super resolution, anomaly detection, data augmentation. Benefits like stable training, demand, fine grained control over output. Some of challenges like high computational demand, slow interface speed, data dependency, key features, training and versatilities, and so on. Practical implementation and popular tools like TLC, stable diffusion, and image generation. So the first things which is introduction of diffusion. So we are going to talk of generative AI and its role, course goal, what is practical techniques and theoretical understanding, applications, and so on. So basically generative AI is an AI role transform randomness data into structure and realistic outputs. Key technology like diffusion model for converting chaos noise into the image and data. So like this application is I'm working in the e-commerce and we have to generate lot of image, right, lot of videos. So if the user trying to generate, it takes the couple of days, but using the AI and ML we can generate within a minutes or second, right? Generative models overview. So we have the VAE, variational autoencoder, generative adversarial network, GN. So people use this one, GN, general adversarial models, and variational autoencoder and auto regressive model. Application: text generation, anomaly detection, data augmentation, art generation. Challenge like training instability, mode collapse in gain, large data requirement. So type is VAE, CAN, and autoregressive models. Application: text generations and channel diffusion model. Core idea: add the noise in which I talk about forward, backward, and impulsive in applications. Okay, this is what I'm going to talk. Model implementation. The architecture is basically on UNet as a base neural network and embedding layers for temporal and context based information, training also, and challenge, and benefits which I talk: stable training, fine grained control over output, versatility and handling multiple data, image, text, and eatings, application: gaming, healthcare, data augmentation, real estate, retail, so many things. So this is what we are going to talk. The first things, what if you could start with pure chaos, noisy mass, and reassembly statics on TV, transform into stunning image? This is not just a fascinating concept, it's a reality. Diffusion model, a groundbreaking approach in machine learning and generative AI. Image algorithm, so experience magics, and which we are going to talk. And fun fact about diffusion. So you need to go. I'm not going because I'm making this video only the 5 minutes, and so it will be over. But basically I'm talking about this course and you can go. So here is input, right? Text, image, speech, data, and the base model, training and application, its use, task, answering questions, sentiment analyze, information. So generative models are fascinating subset of machine learning that focus on creating new database and patterns and structure for given data sets. These models have transformed the way of approach creative technical tasks, machine learning to generate realistic data. So generative models, they have like text based, OpenAI GPT-4, Meta Llama, L Llama, Google PALM 2 birds, other Falcon, and so on. For image, OpenAI use Clip, Dell E2, Meta use image bind same, image generation, stable diffusion, audio, whisper, voice box, and music LM. So this is very important.